I did notice some themes going around. So a lot of people are interested, as it turns out, in I/O performance and disk bottlenecks, I/O throughput. A lot of people are here to find out what metrics are useful and what questions they can be asking of the system. And a lot of people are here to figure out how to present the metrics, visualizations, making better sense of what they've got. So a lot of good topics that we'll be covering today. So
the disk latency one.
Yes.
I think probably everyone in the room went into that. We haven't had a problem with that since we started tracking the latency on every IO. So we track the latency on every IO on every spindle. We store all of it forever, and then every time we have a problem, there's an outlier. And after we started collecting that, we just monitoring will never answer any questions for you. It will only lead you to really, really excellent questions. That leads us to the question that results in action. So we kind of just took all of the magic out of it.
So you record every IOP?
Every latency of every IOP.
Do you do the timestamp as well?
Loosely. So we take it in time chunks. So
Great.
We take it by second.
Wow. So this is almost it's almost just tracing every single event, and I guess
we don't know where it came from. We don't know. I mean, it's completely out of context, right? We just know which box. I mean, because of tagging, it has a UUID basically. But because of tagging, I know what data center, what rack, what box, I know what OS is running, I know what vendor and serial number the drive is, and then I know at this, at 12:06 yesterday, for that 60 seconds, I had 25,000 IOPS, and this was all the distribution of those, and by microsecond. And every time we have basically a set of outliers that shifts, then we go pull our SAT out, our SAS expander, because it just shifts itself. Right? And that's why we started doing that, is because we have a distributed database, and every time we would write to it, we would have these outliers that take 200 seconds, 300 seconds while the drive is deciding if it's still a disk. And then it comes back, and it's like, oh, no, everything's fine. And then it writes it for another 2 or 3 minutes, and then it kicks out again. So, and the average doesn't change, which is kind of the funny part.
What we've seen is that when you do, if you are able to collect and store fine-grained time series of many different parts of your system, some things which are formally very mysterious, and just like, oh, obviously here, these I/O delays, it's the same drive in the same chassis. Every 3 to 4 days, it suddenly decides that it's going to go for a walk, and then when it comes back, everything's fine. And you place that on the drive, and everything goes fine. But if you don't have the ability to just plot that and see, oh, right there, right there, right there, you can spend all your time basically going down a rabbit hole trying to look for it. This is a transient thing, and so being able, if you have a system that can store detailed time series of all of your metrics for a significant period of time, any questions are just very easily answered just by looking at the data you are collecting.
So I have a question for you, Theo. So you're keeping extraordinarily high resolution data here, and these signals seem like they're pretty strong. When a disk goes out to lunch for an hour, right?
Right.
How much aggregation do you think those signals could survive before you couldn't see them?
I think it's highly domain specific. In the disk sense, in our disk sense, you could probably aggregate those up to 5 to 10 minutes and still get the signal out of that noise. The third mode, so you're always going to have like 2 modes on those things, right? You're going to have a set of sequential writes, you're going to have a set of random writes, or read interrupted writes. So you're going to have really fast I/O, and then you're going to have your crappy 10 millisecond I/O, or 8 to 15 millisecond I/O. And then you're going to have stuff that shouldn't happen, which always happens. But if you start having a higher concentration of stuff that shouldn't happen, the question is whether or not you can reasonably detect that mode automatically. And the short answer is I think that detecting that mode automatically is a really hard problem until you tell me it's a disk and that it's I/O latency. Because then suddenly the physical world applies, and I know it's not going to happen less than 0. It should never really be over like 30 milliseconds. That's really bad. So suddenly I've defined the domain of the problem so well that detecting outliers you can apply, I don't know, more discerning math to. So we store all of that stuff minute by minute. We collect it second by second, and then we roll it minute by minute for everything.
Cool. It is 10:30 now, so this is what we can do. We can have a 10-minute break to get coffee. When we get coffee. I know. We might need it. Not that this will be boring, but just because we need to have focus if you're a coffee drinker. When we get back, this is what I will do. I would like to start with disk I/O latency, questions to ask, and then presentation visualizations. So presentation and visualizations is already on the agenda at the end of the day. What questions to ask? I'm already going to make a start on that in the second section on methodologies, because methodologies propose questions. But for the first one, the disk I/O latency, when we come back from the coffee break, I'd just like to go through some material on disk I/O latency. Maybe Theo can do you have a visualization demo you can do of what you're measuring?
Sure.
So I just want to spend maybe 15 minutes talking about the disk I/O latency problem, because it is really, there's a lot of interest in it. Then I'll do posing questions and the metrics that we can come up with to ideally answer all of these different things. We'll likely break for lunch, and then when we come back, we're in section 3 where we're going to go through collection and the stack of, the architecture stack of rolling these statistics up and presenting them. But let's have a 10-15 minute break from coffee to start with.